This is group number 51 and we are performing the simulation experiment 3 based on the spanning tree algorithm. First, let us understand what the spanning tree algorithm is. The spanning tree protocol was invented by Dr. Radia Perlman, a distinguished engineer at Sun Microsystems. Dr. Perlman devised a method by which switches can avoid redundant and loop-free operation. Without the spanning tree protocol, broadcast frames would loop indefinitely, as you can see in this figure. What STP does is, it places each port on the switch into a blocking or a forwarding state to prevent loops. As you can see, this path has been blocked as the port is in the blocking state, whereas these two paths are open for data transfer as the ports are in forwarding state. Data flow in STP occurs in the form of packets called bridge protocol data units. All switches on the network will send BPDU frames to the entire network. The initial process of sending BPDU frames will determine which switch will be the root switch. The spanning tree protocol is a two-layer protocol that passes data in the form of BPDU frames back and forth to find out how the switches are organized on the network, and then takes all this information and uses it to create a logical tree. The simple idea behind a spanning tree topology is that switches can discover a subset of the topology that is loop-free. STP also makes sure that there is enough connectivity to reach every portion of the network. Basically, it spans the entire local area network. Now, let us see how data transfer happens in a spanning tree algorithm. Data transfer begins with the election of a root switch through which all the data will flow. Now, let us see how the election of the root switch happens. The switch ID is made of two components, a configurable switch priority value and the switch MAC address. If none of the switches on the network has had its priority value altered from the default value, the switch with the lowest MAC address acts as the root switch. If the priority value has been modified, the switch with the lowest priority value is the root switch. In this example, we see that the priority values for all three switches are the same, but the MAC address of switch 1 is the lowest when compared to switch 2, switch 3 and switch 2. Therefore, this switch 1 is the root switch. Now, after the root switch has been selected, every other switch determines the shortest path from itself to the root switch. Finally, the source and destination nodes are identified and the shortest path is calculated between them such that it passes through the root switch. Let us understand this with the help of an example. For the sake of simplicity, we will use the terms switch and bridge interchangeably. Consider the example in which there are three bridges, bridge A, bridge B and bridge C. Each bridge has a connection with the other bridges. Observe the bridge IDs of the following switches. 32768 is the priority value of each of the switches and 01, 03 and 02 are the MAC addresses of bridges A, B and C respectively. At the boot up, all of the bridges think of themselves as the root bridge. Let us assume that the first step is that bridge C sends the BPDU frames to bridge A and bridge B, announcing that bridge C is the root with the following root ID as shown here. Note that bridge B's root ID will change from 03 to 02 as 03 is higher than 02, but this will not happen in case of bridge A as 01 is lower than 02. Considering that bridge B's bridge ID is greater than the root ID it sees, in the BPDU, bridge B accepts that bridge C is the root. Bridge A still considers itself as the root as its bridge ID is less than the root ID it sees in the BPDU. Bridge C still thinks of itself as the root. Assuming that the next step is for bridge A to send the BPDUs towards bridges B and C, announcing itself as the root, let us see what happens. We observe that there is change in B and C's root IDs from 03 and 02 to 01 respectively, because 03 and 02 are greater than 01. It has now been established that bridge A is the root bridge. We will now see how data transfer occurs using the spanning tree algorithm by performing the simulation experiment number 3.
Double click on the NetSim icon to open it, and now on the left top you'll find an option called simulation. Click on it, and next to that, new NetSim. This opens up an environment for us to develop a topology. Now click on the switch, the left top, and draw 3 switches on the environment provided. Switch A, switch B, and switch C. Let's now drop a few wide nodes. It's on the left top. Select on the node and the wide node option present, and now drop 3 wide nodes in the environment, D, E, and F respectively. Now read a link to connect these two. Now click on the link option, select the wired link. Now in order to link 2 devices, click on the first device first and the next device second. This will automatically generate a link between the 2 devices provided. And this is how all the links are created. And now click on the application button, drag it and drop on the environment. Right click on the application button, properties. Now in the properties, let the source ID be 4 and the destination ID be 5, because we want the transfer of data from D to E. And the packet size value be 1460 and the value of the interval while time be 20,000 microseconds. Accept. Now let's set the priorities for all the 3 switches. In order to set the priorities, right click on the switch, properties, and you can find 3 interfaces there. Select all the 3 interfaces and change the switch priority from 1 to 2 in all the 3 interfaces present. Yes, priorities are set. Accept. Now repeat the same thing for the other 2 switches. Switch, properties, interface. It's default one, so it's no need to change it again. 1. Accept. The same for the switch 3. Priority must be set to 3. Interface, switch priority 3. The other interface 1 to 3. Third interface 3. Accept. Done. Now, as I said everything, let's run our simulation. Let the simulation time be 10 seconds. It's given 100, now change it to 10. And also the play and record animation in the packet animation. This is just because it will slow down our simulation significantly and allow us to look at the simulation step by step. Okay. You can clearly see the BPDUs are being transferred and configured, and the TCP syncs are also being transferred, and you also find the acknowledgement transferred back. And now our first information is being transferred. As we set the priorities of the switches, A as 2 and switch B as 1. We can find all these values here in the network metrics, the simulation time, packet transferred, packets collided, bits transmitted, payload transmitted, overhead transmitted. All these values you can find it in the network metrics option in the performance matrix on the left if you see. Now click on the view spanning tree option. We can find a spanning tree, and this is how our spanning tree is done. Now path between A and C is not considered because it's forming a loop. Simple. Now let's change the priorities of the switches and see the changes in the spanning tree. Now change the priority, same as the earlier thing we did. Let's not change the priority of switch A. It changed from 2 to 1. And let's now change the priority of switch and the interface 2 and interface 3 as well. Accept. And the priority of the switch B to 2. This is easy. This is the same thing what we did before. Simple. 2. Accept. Now switch C. The same thing we did. It's already 3, so no need of changing it again. Accept. It's done. Accept. Now we have changed all the priorities. Perfect. So as we have said, let's run a simulation. Ensure that the time is 10 and also play and record option is selected. Okay, that's it, done. Okay. And yes, you can find this BPD user configured, TCP ICC, TCP sync, acknowledgement, and how the data is being transferred. Look into this clearly. As we change the switch priorities, the path in which data is being transferred is also changed. This is a magic. This is a magic actually. And now the same as we watched before, the network metrics. You can find all these options here. Simulation time, packets transferred, packets eroded, now everything. Now let's look at the spanning tree. The paths preferred are 1 and 3. The path 2 has been discarded. But because 1 and 3 do not form a complete loop, we have to go from D to E. Path 3 is considered. This is how a spanning turn algorithm can done in NetSim. Thank you.